Hello and welcome to today's podcast. In today's Q&A session, we have Ramesh Natarajan, a veteran with over 42 years of hands-on experience, having an insightful conversation with a guest who is asking him a lot of technical questions. Hope you find this podcast useful to your business. Do visit www.rameshnatarajan.in to stay connected.
Hello and welcome to this episode of my podcast. Today I have with me Mr. Shrinivas, who is a certified energy auditor with more than 2 decades of experience in plant utilities, EHS and project management. With his competency, knowledge and experience, Mr. Shrinivas helps industries in providing sustainability solutions, facilities assessment and project management of greenfield projects. Mr. Shrinivas, welcome to this episode, and I hope we have a very fruitful discussion wherein the battery industry can benefit with our discussion, and you can ask what you wanted about the battery industry and how we will be able to do something which will benefit the industry.
Thank you. It's my pleasure to be on this show and discuss energy efficiency in batteries. Thanks a lot for having me over here. So today we have Mr. Ramesh Natarajan. Mr. Ramesh Natarajan is a battery expert with 3 decades of experience in batteries. He has authored his book, which has got wide publicity on Amazon, Batteries Demystified. So let's hear from Mr. Natarajan about batteries and its impact on sustainability. Sir, when I started my career in industry, I predominantly remember the tubular batteries, and then as we moved on, there were the SMF batteries. So I just have a collection of these 2 batteries. I remember these 2 batteries, but now technology has progressed and there are so many batteries. Almost every household we use batteries, either at home or in the car. So as a battery expert, can you just take us through how the battery technology has progressed and what are the different batteries available in the market?
See, basically, when you're talking of SMF batteries and tubular batteries, both of these are lead acid batteries.
Okay.
Now, when you ask about what are the different types of batteries, basically we have, to start with 2 types of batteries. One is the primary battery, which you use and dispose of, like what you use in your remotes, toys, or the small batteries which are there. And then the second type is the secondary battery. Now, from what I understand, we need to discuss about the secondary batteries.
Yeah.
In the secondary batteries also, there are various types. The most popular and the one which you mentioned in the beginning is the lead acid battery.
Okay.
And when you talk of cars, okay, these were the same batteries which were used in the cars for engine starting, and that is the lead acid battery. But of late, with the arrival of EVs, we find lithium-ion batteries. In the secondary batteries, the various types are, of course, nickel cadmium is also there, sodium ion is also there, nickel iron is there, but then these are not as popular or as well known to the people as the lead acid and the lithium-ion battery. Now, these are the major 2 types which are prominently used. The lithium-ion, of course, came into EVs much later. Lithium-ion was first used in the toys, the cameras, the portable tools, and the very popular use was in the mobile phones. And now the lithium-ion, because of very clear advantages in terms of acceptability of quick charge, and also with respect to the weight, for a car, you cannot have the very heavy lead acid batteries in a EV because then you get less mileage.
Yeah.
So the lithium ion was preferred because of that. So that is how the lithium ion in the EVs have found a lot of, they are very popular in the EVs. And lead acid, of course, continues to be in various applications.
Okay.
The lead acid batteries, of course, are used for stationary applications. Like you mentioned about the inverters, they are used for large UPS systems in industries, especially process industries where they do not want the power to affect the production. They are used in telecom substations. They are used for nuclear power stations. They are used in railways.
Okay.
They are used in material handling equipments. They are also used in golf carts, scrubbers, sweepers, wheelchairs, and of course in automobiles for starting. In fact, I don't know whether you are aware, but even in the EVs where they have these lithium-ion batteries, they still have under the bonnet one lead acid battery of 12 volt.
Okay.
Yeah. And that is still being used, which is a lead acid battery. And of late, lithium-ion is also getting into the material handling equipment segment that is used in forklifts, pallet trucks, platform trucks and all. And lithium-ion batteries are also getting into golf carts and probably into scrubber sweeper segments also. But these are the areas where lead acid batteries may be probably replaced by lithium-ion.
Lithium-ion, okay.
Another thing, when they talk of lithium-ion, they say that after it has been used in the car for a certain number of years or whatever, they are talking about the second life for lithium-ion. And one of the main reasons for this is lithium-ion, as of now, is not so easily recyclable from the economic viewpoint as well as the practical viewpoint also. So they are thinking that after it finishes its life in a EV, they will, put a different capacity to the battery because it will have less capacity and use that in a second life application, which is for stationary batteries, maybe in home inverters or in industrial applications. So that is what they are thinking of using lithium ion. But as of now, lead acid still, because it is recyclable, because it's got a scrap value, and because of various reasons, lead acid batteries are still very popular.
Okay, thank you. That was quite elaborate reply, and it enlightened about the different batteries process as well. What I want to also understand is, normally now we have batteries at every household and we perceive it as a install or fit and forget type of thing. So, but I am curious about it as to how is battery such a simple thing, or how elaborate is the process? You mentioned about the lithium-ion batteries and the lead acid batteries as the two predominant batteries. How are these batteries produced? Because for a layman, it sits in the corner of the room or sits under the hood of the vehicle. So no one ever wonders about how it is produced. So I will be interested to understand from you as a battery expert, what's the broader manufacturing process of the battery?
As far as lithium ion is concerned, I'll first answer lithium ion.
Yeah.
The reason is, in India, they are only being assembled. Most of these lithium ion cells get imported. They are sorted out. They are sorted out for uniformity with respect to voltage and internal resistance and all these parameters, and they basically are then segregated and grouped together and assembled and tested and then given to the people for using. So as of now in India, there isn't a real, so to say, manufacturer right from the A to Z sort of thing. But then when it comes to lead acid batteries, we have a lot of industries, both in the organized sector and unorganized sector also. And there are a lot of recyclers also in India. And, the recyclability, you won't believe, it's almost about 95% plus is you can recycle. I mean, today the battery which I'm using in my car may be containing the lead, which maybe I've used in, probably in my own car about 15 years back or 20 years back, or probably my father has used in his car. I wouldn't know. But that is the condition when it comes to lead. But in lithium ion, that is one major disadvantage. And we say lithium ion, the battery actually has so many components, more than 20 components go in. There's manganese, there's cobalt, there's lithium, and there's graphite, and so many things go in. How are you going to separate out so many things for recycling? And so lithium ion is a different ballgame. Now when you talk of process, well, I can explain you the process of a lead acid in detail, because that's made right from A to Z here in India and by many people. Now, one more thing, I mean, because we're talking of lithium ion and we talked of recyclability, one more thing is, I sometimes wonder whether the people who are using these batteries now in the vehicle, maybe 3 years, 4 years or 5 years down the line, okay, the batteries are guaranteed for 8 years. Suppose we presume that 100% it works for 8 years. What are they going to do with those batteries? Probably these will be the waste battery if no good recycling method is found out or established economically. There is a possibility that the scrap lithium-ion batteries may be considered like a e-waste or a medical waste, in which case it's a catastrophe, because you won't know what to do with all that lithium-ion batteries. I mean, you can't even use it in landfill or anything, because after all, it's a dangerous thing. And when it comes to lead-acid batteries, now you want to understand the process.
Yeah.
Actually, understanding the process in a podcast is quite difficult because it's a highly process-oriented industry. I will tell you the various departments and you will understand that, you start first from taking an alloy of lead and melting it in a furnace and then casting it. And after the casting is done, you cast it as positives separately, the negatives separately. Now, when you talk of automotive batteries, both the positives and the negatives are a mesh-like structure. But when you talk of tubular, the positive is a spine type and the negatives are a mesh-like structure. So they are different. Now, different types of batteries and different AH capacities, the standardization is not very easily possible, especially when it comes to industrial batteries. In automotive, you have some sort of standardization, and by changing the number of plates, you can increase the AH, and it's somewhat possible. But even there, basically, you have three types. There's a standard grid, there's a Japanese narrow type grid, and there's a DIN German type grid. So the sizes vary. So these three types are there. And when it comes to industrial, you have many types. Okay. And then, so you cast the grids, and then the next thing is you have a mixing department where lead oxide is mixed with acid, water, and certain chemicals, and that mix is applied to the grid. When it comes to tubular, you have a filling department where the powder is blended and filled in the tubular positive plates. Now, after the mix has been made, it is applied in the pasting department in the case of negatives. In the case of automotive, for both positive and negative, you make different type of mix and apply it. So, basically, we've finished, I mean, not finished, but I have mentioned to you a casting department, a mixing department, a pasting department. And when it comes to tubular, a casting department and a filling department. Now, after the filling, in the case of tubular, you go to pickling. But in the case of pasted plates, you go to something known as a curing operation. And after the curing, you have a drying. And then there is an option. You can take the pickled dried plate, and you can take the cured plate and you can form these plates, that is, charge these plates. Or you can directly take it to assembly and charge these plates after the assembly in a battery container. So there are two options. Some people do the formation and then the assembly. Some people do the assembly directly. And after that assembly is over, then you take it to the charging department where you fill it with acid and charge the batteries. And that's how you have a ready battery. Now, this process, though it seems simple when I mention it within 3 minutes or 5 minutes, actually the process takes more than about 20 days because after the casting, you have something known as age hardening. And so the grids are kept like that for 2 to 3 days. After that only it can be taken for pasting. Again, after the pasting, when you do the curing, that's another 48 to 72 hours process. And then you have a drying of 24 hours. And then you have some intermediate processes like lug brushing and then making of the components for the assembly, like the connectors, the pillars. Those are also ancillary jobs which are also getting done simultaneously, and then only in the assembly you can assemble. After the assembly, again, after the acid filling, you cannot directly charge because it gets heated up. The electrolyte gets heated up. So you give it a rest period, maybe about 6 to 24 hours, depending on the ambient and depending on what is the type of plate, whether it's a form plate or an unformed plate and all that. So all these things usually take about 20-21 days right from the day you have put the lead into the furnace. So it's not a very simple process. So, and the charging is also very important. Just assembling a good battery with all the right chemicals. You also mix certain chemicals like I mentioned in the mixing department, but it's not so simple. And even if you made a very good battery, the charging is very important because you can bugger up by either overcharging, heating up the battery, doing a fast charging, or using a charger which doesn't have proper filters and all those safeguards need to be taken care of. Otherwise you have a lot of ripple current going into the battery. All these things are there. So the process is very important. The quality person has to check at each stage of manufacture and certify it for the next process. So that's when it comes to process.
Okay, thank you. So the process, though the battery seems to be compact, the process is quite elaborate. I'm still in between the positive and negative plates, but it's quite an elaborate process. So that brings me to a different question which I'm thinking upon is battery is now perceived, actually it will be the prime mover for all the vehicles and all the having a green footprint, a less environmental footprint. So if we consider this elaborate process, how is it from an energy perspective? Is it energy efficient? Are there any opportunities for improvement in energy in this process? Because what I understand from you seems to be a quite elaborate process. It takes almost 21 days to manufacture a battery. So if we see from its own footprint, energy footprint, how do you see this process?
See, naturally, when you say that you are in the, process industry, there is definitely scope in various departments for saving electricity. Now, in the casting department itself, what people do sometimes is when they melt the lead, they keep the surface of the lead open. So there is a lot of drossing. And because of that drossing, not only are you generating more scrap, but usually what happens is the surface atmospheric temperature cools the top. So one of the methods which I always advocate is put charcoal on the top. Not only is that a reducing agent for reducing your draws, but it also retains the heat inside. So this is one area where people can save a lot of electricity. Okay. Now the second thing is when compressed air is one thing which is used in various departments for running the various machines. But unfortunately, people have a feeling that air is free. Okay, they will be concerned about usage of water, concerned about usage of electricity. But when it comes to air, there is a lot of, it's a myth that it's free. Air in the atmosphere may be free. Maybe. Okay. But then when you're compressing air, you use a lot of electricity. And suppose there is any leakage in your pipe which you run around all through in the industry, and if there is a leakage, the compressor is going to start again to fill up the tank. Naturally, your electricity is getting consumed. So basically, air is not free. There is one particular department known as pickling department, in which the people want to bubble the electrolyte when the pickling operation is carried out. Now this bubbling, because the air is available and the pipes are going all around, they take a branch out and they put the pipe in and pickle. In the pickling department, they use compressed air. There is no need of compressed air. You don't need air under pressure in that department. You only need some air velocity to keep the liquid bubbling. So what happens is, there also I advocate a lot, and I say either use a blower or a simple device like what is used in a fish tank can be connected, and they can use that, and that itself also serves the purpose. That is one area. Another area where people also neglect is in either plate formation or in battery charging. Formation is also the charging of the plate. So though we call it formation, it is charging basically. So you are charging plates in the formation department and you are charging batteries in the battery charging department. In both these areas, they have to use chargers which are more efficient. So it's a question of using equipment which is good and efficient for you to save on power. Another thing is, many a times people feel that feeding in more current or for a longer duration is a good idea. You will get more capacity, which is not true. You have to feed the right amount what is required for the battery. Feeding in more and overcharging a battery does not serve any purpose, and that is one more area where a lot of power is wasted. Now, when I say there are so many processes, what happens is, naturally there are going to be so many people, there are going to be so many workstations, and there are going to be so many quality inspectors also at various workstations near the production area. Now, here also the tendency is use one big lamp and 500 watts, 1000 watts or whatever, or okay, even if they've come to LEDs now, they'll use a 200 watts LED and light up the area. But then lighting up the area doesn't serve the purpose. It's better to have smaller lamps, more efficient, focused near the work stations where the people are sitting, and there also there is a lot of scope. So instead of having 200 watts or something, if you focus and do this lighting in areas where work is being carried out, you may end up using only 80 watts rather than a 200 watts. And similarly, all these lighting around the factory also, because when you are having so many processes and when you are having so much of manufacturing, naturally the the industry is going to be very big. So you have a lot of light all around. So all these places also, electrical audit, energy audit needs to be done, preferably once in 2 years or 3 years, and then a lot of saving can be done. And of course, gensets also, which are used many a times, because the power requirement in a battery industry is very huge. So the genset which is required are also of big capacities. You cannot use a 35 kV or 60 kV and run an industry. So you are going to buy a very big genset. Many a times, especially in the small scale sector, people then start looking for a second hand genset or a used genset. But again, one has to be careful that the genset is well maintained and good, and there is no wastage when it comes to genset also. Otherwise, you have a lot of inefficient gensets being used. And of course, compressor I have already mentioned to you. The compressor piping has to be such that there are no leakages, because you're taking it all around the factory. You're using pneumatics in the pasting department. You're using pneumatics in the filling department. You're using pneumatics in the casting department. There are a lot of pneumatic cylinders used in the heat sealing in the assembly and various areas. So the pipe runs through almost the entire factory, the length and breadth. And I would always advise use pipes which don't leak. Preferably don't use flexible pipes. And now there are a lot of people, there are aluminum pipes available and they are sealed, and they do the piping, and it's worth using those agencies and getting those things done. Of course, there are a lot more areas, but I can't think of anything as of now.
I think that's a lot of elaboration. You have taken us through a detailed tour of the plant along with the process, how energy is flowing in and out. So battery, though it's giving us the energy, how the battery manufacturing process consumes energy, you have given a very detailed thought to it, and your tips are worthwhile, because what you said is air is free but compressed air is not. The another advice which is worthwhile to reflect upon is related to the DG sets, because people always think that buying an older DG set, a used DG set, is actually not a saving, but it is going to be inefficient addition to the process. So
why is the, think of it another way. Why is somebody selling a DG set? Definitely he has used it. He has realized that this DG set is inefficient and I am now going for a new DG set or something like that. Maybe the reason why he says, oh, let's get rid of it. And then at that time when you're buying a DG set, you only think, oh, I have to generate power. But is that the only thing? At what cost are you going to generate that power? Right. And what is your running cost? And the more your usage, the more the losses.
Right, that's right, and I believe this input will be of useful for all our listeners. So thanks a lot for taking us through this, and it's really battery demystified. Along with batteries, you also demystified a lot of other myths related to energy, and I'm thankful to you for sparing your time. And I again urge the listeners to go through this book, Battery Demystified, which you'll uncover a lot of facets about battery, which is going to be the prime mover of everything, and it will be a household thing. It is now, but its utilization will be much more multifolds, and in that context the knowledge of battery will be definitely useful. So thanks a lot, sir, for giving your time.
Thank you, Mr. Shrinivas, and as you rightly said, I hope this conversation will be helpful to the battery industry, and all the manufacturers will benefit from our interaction. Thank you.
Thank you. It's my pleasure. And I'm sure this discussion, actually, you gave a lot of insights which help to understand more about the battery manufacturing process. And I could also understand that this process has a lot of potential for energy saving. And if rightly the listeners interpret it, they will be not only be able to improve the efficiency of the process, but also reduce the environmental footprint. So thanks a lot for having me over here.
Thank you, Mr. Shrinivas.
We hope the Q&A session was useful and insightful. You may contact us by writing to rameshnkailad@gmail.com. Please do visit www.rameshnatrajan.in. Keep yourself updated about our new releases by hitting the subscribe button.